Hi everyone, so the reason why I'm doing this video is because we haven't done proofs in a long time, we haven't had time to consolidate it even, and the proof structure, I imagine, is starting to fall apart. Secondly, aside from proofs, identities and solving quadratics involving trig for that Christmas quiz was dire, okay? To put it frankly, it wasn't up to scratch, so I think we need another reboot of that. So that's what this video is all about. Please don't skip the video. Uh, at least follow the first few examples with me, and then you can try and then check. But you must check, and the layout for proofs must be how I'm setting them out. All right? It's very precise, just like in M1. There are certain things that that can't yield. I promise this video won't be longer than 15 minutes. At 15 minutes, we will just cut dead. So let's go. So we identify left-hand side and right-hand side. Can't do anything with the right-hand side, so I need to start with my left-hand side. I quote the left-hand side exactly as it is. And now I can start working with it. And remember, those three lines there means always equals to. So it doesn't matter what values of x go in there, it will always work. Doesn't seem like I can do much else apart from expand those brackets. Remember, I've got to ignore this 5 now. To me, that 5 doesn't exist until I've proved that this thing will end up as 5. The worst thing people do is when they start going 5 and then start working on the left and then the right 5 and they keep writing 5 all the time. No. The idea is you are going to make this look like 5, right? So let's try it. Let's expand out this first set of brackets then. So 2 sine x minus cos x all squared. That's 4 sine squared x minus 4 lots of sine x cos x plus cos squared x. There's that bit. And now we've got plus. So plus. And now this section. So sine x plus 2 cos x all squared. So that's sine squared x plus 4 sine x cos x plus 4 cos squared x. So again, if you need to pause the video and work that out for yourself, go ahead, that's fine. So notice the minus 4 sine x cos x cancels the 4 sine x cos x. Done. So we're left with 4 sine squared x, that's that bit, plus sine squared x, so that's 5 sine squared x. And we've got 4 cos squared plus 1 cos squared, so 5 cos squared x. Where can I go from here? Hopefully you're thinking about it because you know your two identities. You must know these identities. If you don't, just keep writing them out. Write it out until you've got it. Sine squared plus cos squared is 1. Tan x is sine x over cos x, yeah? So can you see here, if we take out a factor of 5, we have sine squared x plus cos squared x, which is 1, and therefore we're left with 5, which is our right-hand side as required. QED or fill in gap, whatever. But notice that this is completely blank of work, isn't it? That means your layout is good. If I can do that under your work, your layout is good. Number 2, let's try again. So identify left-hand side, right-hand side. It's always easier to make things bigger, expand them, than it is to reduce things down. So as soon as I see something all squared, I'm like, I think I'm going to start with that. So on the right-hand side, I quote that, so right-hand side, underline, sine plus cos x, all squared. Let's see what we get. So sine plus cos squared is the same as sine squared x plus cos squared x plus 2 sine x cos x. Cool. This is looking good, except now we need a bit of trickery then to get this sine x minus cos x. And yeah, looking at it, I can see this isn't going to work because I've copied the question down wrong. So that one needs to be squared. Let's quickly get a square on there. Cool. That one needs to be squared. So actually, now I look at it, I don't really like the right-hand side now. I'm going to do the left-hand side because there's more stuff on the left-hand side and therefore more for me to work with. You see, expanding is always easier than shortening. So sin x minus cos x all squared is sine squared x plus cos squared x minus 2 lots of sin x cos x. Right, trying to make it look like this thing. And just as a side note, well, what is that thing? Well, that is sine squared x plus cos squared x plus 2 sin x cos x, isn't it? That's what that is. So that's what I need. So if we look at that, if we expand out the bracket, so 2 minus sine squared x minus cos squared x plus 2 sin x cos x. I've got my plus 2 sin x cos x. That's a good start. Sine squared plus cos squared. I know that sine squared plus cos squared, well, I know that's going to end up being 1. I'm quite close here, aren't I? So 2, can you see that 2 is the same as 2 times sine squared x plus cos squared x, isn't it? Because sine squared plus cos squared is 1. So you're always looking out for when can I use my identities. And now you can expand out. Squared x plus 2 cos squared x minus sine squared x minus cos squared x plus 2 sin x cos x. Cancel, 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 cancel. You're left with sine squared x plus cos squared x plus 2 sin x cos x, which is the same as sin x plus cos x, all squared, which is the right-hand side as required. Okay, you see that spotting? You're kind of cheating by looking at the right-hand side and going, oh, what's that roughly going to be? But I'm not quoting it anywhere. And notice here, I've got my empty space, so my layout's good. Okay, last problem then for the proofs. Nice and quickly. Again, it's easier to work. Doesn't really matter which one I work with actually, but I'm going to work with the, well, it's easier, like I say, to put things together than it is to split them apart. So I'm going to work with the left-hand side. It looks like I'm working with the left-hand side all the time, but it's not always the left-hand side. It's just whatever I feel like. But in general, what you can bring together or expand, that's the one you want to choose to the start. But there's no right or wrong answer. So I've quoted the left-hand side. I've got two things. Looks to me like if I've got two fractions, but on here I don't, I need to put these two fractions together. How do I do that? Well, I need to make the denominators the same. Now I can put this together. Oh, what's 1 minus cos squared x? Well, again, if you know your identities, if you know sine squared x plus cos squared is always equal to 1, therefore cos squared x must always equal 1 minus sine squared x. And likewise, sine squared x must always equal 1 minus cos squared x. So therefore, this top is sine squared x over cos x. Remember, we want sine times tan, and tan is sine over cos. This thing here is sine x over cos x, all times by sine x, isn't it? That's how you get sine squared, which is tan x times sine x, which is our right-hand side as required. Sweet. Okay, back onto the solves. So that was the proofs, now we're on to solves. Let's just really make sure we've got our method tight. So principal value first, isn't it? So 2x plus 0.2, whatever's in that bracket, that stays. Cos to the minus 1 of that minus 0.2. We're in radians, so calculating radians, cos to the minus 1, minus 0.2, and you get 1.772 because our answers will be to 3 sig fig, so we calculate to 4 sig fig. That's our PV, but we also need minus PV because it's cos, isn't it? Done. What's next? Yes, you're all thinking domain, exactly. So I started with x between pi and minus pi, but this time I need 2x plus 0.2. So pi times 2 plus 0.2, 6.483. Minus pi times 2, whoops, minus pi times 2 plus 0.2 is minus 6.0831. So now I've got 2x plus 0.2, this is my solve section, is 1.772 minus 1.772. Now I'm going to add and subtract the period, which is always 2 pi for cos. So 1.772 plus 2 pi, 8.055, too big, minus 2 pi, minus 2 pi, minus 4.511. Great. Same with our minus 1.772. You'll notice that cos is symmetrical, so I am expecting plus or minus the same answers, which I do get. And if you minus 2 pi, yeah, it's not going to work. Fantastic. And then our solve. So x equals 1.772 minus the 0.2 first, divide by 2, and we've got our 0.786. Our minus 1.772 minus the 0.2, divide by 2, and we've got minus 0.986. Minus 4.511 minus 0.2 divided by 2 is minus 2.36, and 4.511 minus 0.2 divided by 2. Notice these answers are not symmetrical when you adjust, so it's very important you don't skip steps. Done. 3 minutes. Okay, last example, solved. This looks tricky, doesn't it? This looks tricky. Somehow I've got to solve this thing. I reckon there's going to be links here with cos squareds and sine squareds and stuff, as in the 1 minus cos squared, 1 minus sine squared. Maybe something to do with that. Not sure yet. So we're just going to try some stuff because it looks quite hard. So let's try. I reckon as there's a sine squared and a sine there, how about we start by moving this over? So if I was you, this is exactly what I'd be doing. I'd be testing things. What happens if I took out a factor of sine? So I get 2 sine x minus 3 cos x is 2 cos squared x. Difficult. No. Not going to work. I think I've seen a cheeky problem here. You're right. So we could try that. Didn't work. Could try 2 sine squared minus 2 cos squared. No, that's not going to change to anything. This is interesting. We know 2 identities, don't we? So you could spend a long time trying to fiddle with this. But there's also another identity. Tan x equals sine over cos. So at first it looks like, oh, I've got to manipulate my cos squared and sine squared. But actually, can you see what would happen if you divided everything by cos squared? 3 sine x cos x over cos squared plus 2 cos squared x over cos squared. 2 sine squared over cos squared is 2 tan squared. Which is not always equal to 3 sine x cos x over cos squared is the same as 3 tan x, isn't it? Because that leaves you with 3 sine x over cos x plus 2. Now we get 2 tan squared x minus 3 tan x minus 2 is 0. And now we have a quadratic in terms of tan, which we can factorize. So we could say 2 tan x, 2, 0, minus, plus, and therefore tan x is minus a half, tan x is 2, and now we would solve, right? So remember the period is pi this time, but we're at 15 minutes, so I'm going to stop there and you can carry on if you wish. Remember to check your answers. You can just plug it all in, pick 3 random values. If they work, fantastic.